In this section, we're going to work on interpreting the rate of change and the y-intercept in real-world problems. The T-Mobile One family plan includes 4 lines and unlimited data, calls, and texts for $160 per month, including taxes and fees. There's an activation fee of $80. So we've got this whole plan is 4 lines, unlimited data, calls, texts. It's $160 per month, which includes your taxes and fees, and an activation fee of $80. Define the variable and write a function that represents this situation. So variables are going to represent things that can change. One thing in this scenario that will change is how many months we have planned. So X will be number of months. And when we change the number of months, we will change the total cost. So that'll be Y. Then we need to write a function. So to find the total cost, we would take the cost per month times months. And then we also have to pay the activation fee, but this is a one-time payment, so it will have no variable on the end of it. It's just Y equals 160x plus 80, so $160 a month plus the $80 activation fee. Represent this situation on a graph. So X was number of months. Y was total cost. We're only working in the first quadrant because we only need positive numbers. So the bottom left-hand corner will be the origin. And we'll count by ones for months. And let's count by 80s for cost. So 80 times 1, 80 times 2, 80 times 3, 80 times 4, 80 times 5, 80 times 6, 80 times 7, 80 times 8. That'll be good for now. And let's build a graph of this. So if we have 0 months, so if I put in a 0, I'll get out an 80. If I put in 1 month, I'll have 160 plus 80, so I'll add 160 and get 240. And add another month. So if I put a 2 in there, I'll have 320 plus 80, so 400, and so on and so forth. So at 0 months, I owe $80 because I had an activation fee. And so this will be my y-intercept. And the 160 is the slope. So I'm going to pay $160 per month. So 1 month passes. I need 160 extra dollars. So there's 80, 160. So I'm going up 2 boxes because that's the equivalent of $160. Add a month, go up $160. Add a month, go up $160. Add a month, go up $160. And this pattern will continue. So it was add a month, add $160. What was the slope of this line? The slope is 160 over 1. What does it represent? It was $160 per month. So each month costs $160. At what point does the line intersect the y-axis? So our line is going to cross the y-axis right here at 80. So that's the point 0, 80. What does this point represent? This is our starting value or the initial value. So the initial value is $80. This was our activation fee. So it was that one-time payment. The y value of the point where the graph intersects the y-axis is the y-intercept, so 80. Let's try another one. You saved $250 to spend over the summer. You decide to budget $25 to spend each week. Define the variable and write a function that represents this situation. So you saved $250. You're going to budget $25 to spend, so that 25 is going to be taking away from your 250 each week. So things that can change in this scenario would be the number of weeks you do this for. And when that changes, it will change the amount of money you have left. So X will be the number of weeks, and Y will be the money left. So the weeks is going to control the money, so weeks needs to be X. And our equation, you're starting with $250 and you are going to spend or take away $25 each week. So that's 25 times weeks. And then we can go make a graph for this. The X was number of weeks. Y was money left. Again, we're only operating in the first quadrant, so the bottom left-hand corner is 0. Count by ones on the x-axis. And let's count by 25s on the y-axis. So 25, 50, 75, 100, 125, 150, 175, 200, 225, 250. Okay, and then we can make our graph. So just to give an idea of what's happening here, we can start a chart if it's been 0 weeks. So if I put 0 into my equation, I'd have 25 times 0, which is 0, so 250. And then 1 week, so if I put a 1 in here, 25 times 1 is 25, so 250 minus 25 is 225. So it went down $25. Another week passes, so if I put a 2 in here, now 25 times 2 is 50, so 250 minus 50 is 200. It went down $25 again. So we're starting to see a pattern here. At 0 weeks, I had $250. 1 week passes, I lose or spend $25. So 1 week, down $25. Another week passes, down $25 more. Another week passes, down $25. Another week passes, down $25. Another week passes, down $25. And so on and so forth until, oh no, I have no more money. And that happens at week 10. So that would be no money. What's the slope of this line? We were going down 25 and over 1, so that would be negative 25 over 1 or negative 25. What does the slope mean? The slope means you are going to spend $25 each week. So spending means negative. What's different about the slope of this line compared to our earlier problem? So in our earlier problem, our line was going uphill and we had a positive slope. Now our line is going downhill and we have a negative slope. So the slope is negative. And it's negative because we're spending the money. we are physically taking it away from the money that we have. So the amount of money left is decreasing. What was the y-intercept? The y-intercept is your initial value or your starting point, which is $250. So our y-intercept is 0, 250. What does it represent? It represents that we start with $250. Okay. Another example, consider the following graph. Cost of visits to the community pool. X is the number of visits to the pool. Y is the total cost in dollars. Question A, what is the slope of the line? What does the slope represent? So let's find a couple ordered pairs that we can read. Looks like we have a 2 and an 8. And maybe a 4 and a 12. So spread them out a little bit this time. Okay, so our slope, we need a rise. So straight up, straight over. We are going to rise 1, 2, 3, 4 boxes. They are counting by 1, so I went up $4. And I went over, or my run is 2, and they're counting by 1, so that's 2 visits. So slope is 4, 2, rising 4, running 2, which is 2 over 1. What does this mean? Well, the 4 is in dollars, and the 2 is in visits. So this 4 became the 2, so this is $2 per visit. So it costs $2 every time you visit the pool. What is the y-intercept? So that's where our line crosses the y-axis. So that is 0, 4. What does the y-intercept represent? For some reason, it costs $4 to never visit the pool. So maybe we signed up for a discount card, or maybe you have to pay a towel fee. It's just a one-time fee. So there's a one-time $4 payment. So I'm just going to say it's a sign-up fee. It costs $4 to sign up to use pool. Define the variables and write a function. So X was the number of visits. Y was the total cost. So to find the total cost, you have to pay $2 per visit. So $2 per visit. So 2 times X. And for some reason, you had to pay $4. So that was our sign-up fee. So $2 per visit plus $4 to sign up. And what does each point represent? So our ordered pairs go X followed by Y. And our X was the number of visits. And Y is the total cost. So each ordered pair will show you how many times you visited the pool and the total amount of money you've spent. Consider the 3 functions that you wrote regarding the cell phone plan. That was y equals 160x plus 80. Summer spending habits. That was y equals 250 minus 25x. Well, we might have used w, but. And the community pool membership. That was y equals 2x plus 4. What do you notice about the constant term and the coefficient of the x term? So in this equation, our constant, the term that does not have a variable, was the 250. In this one, the constant, the term with no variable, is the 80. And in this one, the constant is 4. So if you look back at all of our examples, the constant term is the y-intercept. The coefficient of the x, so the number that's multiplied by x, so in this case, negative 25, 160, and 2. What was that number every time? That number was the slope, or the rate of change. These functions are written in what's called slope-intercept form. So y equals mx plus b, where m is slope and b is your y-intercept. And in the next section, we're going to use slope-intercept form to help us make graphs.